second one?
Using cyanide.
That's right. So we're going to do an SN2. So I'm gonna make it just like what you have in your notes. So your notes will make sense. Did this make sense?
Yes.
All right. And once we do this, I'll give you guys a problem about this. So, okay. So now, for this one here, we're doing an SN2 using cyano group followed by hydrolysis. Alright, so now if I say hydrolysis, what should pop up in your mind? It's okay if you don't know, it's fine.
Yeah.
That's right. That's exactly right. It's exactly right. If we're doing hydrolysis, we must start off with some carboxylic acid derivative. And in this case, it's going to be a nitrile. Right? So remember, we had acid halide, anhydride, carboxylic acid, ester, amide, and then nitrile. The cyano group is going to generate that nitrile, and then we're going to follow with a hydrolysis. So we can have H2O acid, or in basic condition and heat. Right? That's what you're seeing here. I'll write it out. You have the nitrile here, and you do a hydrolysis and turn it into a carboxylic acid. Right? So we kind of talked about that before, right? But let's look at it more carefully. Right? All right. So we're starting off with this. So he shows a little bit of stereochemistry here. Yeah, this is definitely an OH. Definitely an OH. And we're going to react this with so it might have been like this actually. This is a tosylate. I think you might have missed a carbon here. This is CH3.
I don't think he wrote it, stuff.
Yeah, no, he didn't write it.
So that's, was that a toxic chloride?
Yeah, that might have been what he was trying to write. So this is
Yeah, that's the OH because you would.
right. Yeah. So this guy here, he just shows what happens in the reaction, right? Well, actually, he didn't show it out, right? He didn't write it out. So basically, this guy here is gonna go here, and this guy's gonna get kicked off. Then this guy, yeah, that'll be it. And this guy here, we get deprotonated by the pyridine. So this here, this little base here, you have to decide here is the pyridine. So the reason why we're doing this is, remember, OH is a bad leaving group. So what we gotta do is we gotta protonate this guy. Either protonate him to, you know, get a positive charge here so we can leave, or we gotta use the tosylate, the mesylate, or the triflate on there. Tosylate is really good. So if we react this guy with tosyl chloride, we can generate a good leaving group here. And it would form sorry?
So did he leave off the note too?
Yeah, he must have left. So this is a good leaving group now. Right? So now this is a good leaving group, and we can now do an SN2 reaction on this. And what are we doing the SN2 reaction with? Cyanide. That's right. And whenever we do an SN2, we get an inversion of stereochemistry. You guys remember this? SN2. Well, actually, it's not an inversion of stereochemistry. It's an inversion of the geometry, or it's an inversion of the configuration, which can lead to an inversion of stereochemistry. It might, but it will not always lead to an inversion of stereochemistry. So we will always get an inversion of configuration. All right, so that's what he's trying to show here, right? That's what he's trying to show here. You can kind of see how this was in wedge, and then now he put it in dash. Right. And I'll draw this out. It's supposed to be in wedge here. And we set a hydrogen. This is a hydrogen. So this guy comes in here. Like that. And he does a backside attack and kicks out this guy. He does an SN2, right? Now this guy here is now going to take the wedge. Right on this side, and whatever is here, this hydrogen will take the dash. That's what you have there, right? Well, actually, no. Right. This. Yeah, that's right. The hydrogen will take the wedge, and this will take the dash. Right. Right. And now this is a nitrile. All right. And this is a carboxylic acid derivative. So what can we do to carboxylic acid derivatives? That's right. So this guy can be hydrolyzed using H2O and acid and heat. Or you might just see H3O plus. It's okay. Right? And all that's going to do is it's going to turn this guy into a carboxylic acid. Now this is the carbon of the carboxylic acid. That's that carbon of it. So we would have this. Stand behind.
Do we show stereo?
Let's see. Did he show it? Okay, he showed it. So. Yep. Cool. Does it make sense how we did this?
So basically, can we just go back to the first step for a second?
Yep.
I was a little confused, like what happened with that oxygen.
This thing here?
Yeah.
Okay, so the major thing you got to know here, this is organic 1. It's just OH is a bad leaving group. We want to turn it into a good leaving group. And we can just do an abbreviation here. Like, this was in an exam scenario. Most professors are okay if you just put, like, this is an abbreviation because it's a big, huge, humongous group. Most professors are okay if you just write this. So whenever you see this, it's a tosylate, or tosyl chloride, and it's followed by pyridine. It's trying to turn this guy into a good leaving group, so we can then do another reaction on it.
Okay. So basically, it seems like it replaces the hydrogen now.
This one?
Well, you keep the oxygen, but then everything else like adds.
Oh, okay.
Like, the chlorine goes away.
Oh, okay. Okay. No, it's fine. It's fine. It's a good question. So if you're confused about something, just let me know. It's fine. So when this goes here, it's gonna kick out this chlorine here, right? Kicks out the chlorine here, and we would have this. There will actually be a hydrogen here. This hydrogen will still be there, but that's why this pyridine is here. The pyridine would then deprotonate that hydrogen, so that you would have this.
All right, that makes more sense because I was like confused about what happened to chlorine, but okay.
Cool.
Yes.
So we just saw two ways to generate a carboxylic acid. There's actually more ways, right? But that's what these first two is about. Synthesizing the carboxylic acid using a Grignard. What did we react the Grignard with? What did we react the Grignard with?
Oh, CO2.
That's right.